Welcome to this NBT Preparation tutorial. Today we'll be doing some of the exemplar NBT questions, and in the following video I'll be finishing off the rest of the questions. Now let's get to it. Question 1 says the function f defined by y equal to f of x equal to negative x squared plus 6x minus 5 has. Right, before we try to solve or try to find the solution of this question, it is often easier to try and eliminate the wrong answers first, especially if you're dealing with multiple choice questions. So in this case, we know that we are trying to find if this function has either a minimum or a maximum y value, and if it either has a negative or a positive y-intercept. Right, so now that they talk about y-intercepts, we know that given that fx equal ax squared plus bx plus c, the c value is actually our y-intercept, right? So in other words, we already have the y-intercept, which in this case is this value, negative 5, right? So in this case, we have this value, negative 5, which means our y-intercept is actually negative 5. So we know that our y-intercept should be negative, right? So B and C have positive y-intercept, which means B and C are actually wrong. So we can actually cancel these out. So now it's easier to work with a set of 2 choices instead of working with a set of 4 choices in this case. So right now, let's try to work the other choices that we have. We know that the answer is either A or D in this case. So what do we need to find now is if this function has a minimum y value or a maximum y value. Now, we know that this type of function, which is a parabola function, has this type of shape if A is positive, and has this type of shape if A is negative. Right? So if A is positive, it has a minimum value, which means this is the lowest point, the lowest y value that it can actually have. But it only occurs when A is positive. If A is negative, it means it has a maximum value at the turning point, right? So if A is negative, it means our y value of the turning point has to be a maximum. So y here has to be max, and y here has to be min, because we can see it's actually the lowest point, and here we can see it's actually the highest point. So now when we look at our function that we have negative x squared plus 6x minus 5, and our A is negative, which means we are supposed to have a y value that is a maximum, which means our answer is D, which says a maximum y value and a negative y-intercept. Right, question 2 says the sum of the roots of the equation negative x squared plus 6x minus 5 equal 0 is, and now let's try to find the roots of this equation. So we have negative x squared plus 6x minus 5 equal 0, right? So it's just a personal thing that I don't like to work with negatives in front of x squared. So what we're going to do is we're going to divide everything by negative 1 so that we can cancel this negative x squared. So we're going to divide by negative 1, divide this by negative 1, divide this by negative 1, and also divide this by negative 1. We are going to get x squared minus 6x plus 5 equal 0. Now we are trying to factor this to find the factors, actually the factors of this expression. Now we are looking for factors of 5 that when we multiply we should get 5, and when we add or subtract we should get negative 6. So we are looking for 2 factors, a factor that when we multiply, 2 factors that when we multiply should give us 5, and when we add or subtract should give us negative 6. Right. Now, what are the factors of 5? The factors of 5 are actually 1 and 5. So we can either multiply 1 and 5, because 1 and 5 gives us 5, but 1 plus 5 gives us 6, which is not negative 6, and 1 minus 5 gives us negative 4, and 5 minus 1 gives us 4. So it means 1 and 5 cannot be the factors. So we can try negative 1 and negative 5, because negative 1 times negative 5 gives us 5, and negative 1 plus negative 6, plus negative 5 gives us negative 6. So it means the factors that we're looking for are actually negative 1 and negative 5. So we can come and say x minus 1, x minus 5 right here. Right. Now we know that x is supposed to be 1, or x is supposed to be 5. Now they say the sum of the roots of the equation. It means now let's try to find the sum. The sum is actually 1 plus 5, which is 6, and 6 is D in this case. Question 3 says the expression root of negative x squared plus 6x minus 5 we're trying to see if it has a maximum or a minimum value at certain values. Right, this is rather a tricky question, but let's see what it means. I'll try to solve it using multiple methods. Before we solve for this expression, we first need to know what this expression is. So this kind of an expression resembles an equation of a semicircle. What do I mean by that? So we know that a circle is like this. Let's say it's a basic circle, right? An equation of a circle is x, I'm sure you know this by now, x minus a squared plus y minus b squared equal r squared. But if I say give me the equation of just this part, how would you represent this, right? So the equation of a semicircle, we say it is x minus a squared plus y minus b squared equal r squared, but we give it a restriction of y should be greater than or equal to b, because it makes sense that this y value should be greater than b, because b is actually the center. If we want the upper part, we need y to be actually greater than the y value of the center. So saying y should be greater than or equal to b gives us the equation of the upper circle, which is the semicircle. And if y is less than or equal to b, we get the equation of this lower part. So now let's see if what we have here tries to resemble, let's say for example, y was 2b. In other words, y is greater than or equal to b. It's actually greater than b, but it follows this restriction. So in other words, if we say let y be 2b, this is an example, by the way. I'm trying to make you understand that this is actually an equation of a semicircle. So let's let y be 2b. This is an example. And if you are not comfortable with whatever I'm doing, you can skip to the part where I actually solve the problem. But I am trying to make you understand first that this is actually an equation of a semicircle. Right, now let's say we let y be 2b. In other words, we're going to have x minus a squared plus 2b minus b squared equal r squared. Now let's make r the subject of the formula. In other words, we're going to have r, and we're going to have a square root of, let's multiply everything out. We're going to have x squared minus 2ax, and this is going to be 2b minus b, which is b squared. So we're going to have b squared. Oh, we forgot to square this a, so let's square that. Let me erase this real quick. Let's square this a, so this is going to be a squared plus b squared, right? Now look at this. Look at how similar this is. Don't forget that we took a random 2b, so I'm just trying to show you that this is actually a resemblance of this. Now look at what we have here. We have x squared, negative x squared, plus 6x minus 5. Now, you see this part of the x squared, which has 1 here, is represented by this. And this part of negative 2a and x is represented by 6 and x. And these are constants because they don't have the x attached to them, which means they all are represented by this negative 5. So this is a resemblance of an equation of a semicircle. And if this is positive, which means our y is positive, it means it's actually an equation of a semicircle of the upper side. And if y was negative, let's say negative, whatever would be in here, it means we would be looking for the equation of the semicircle of the bottom part. Now, let's solve the equation. Now, for the method that I want to use is actually a simple one. We are actually going to try to plot this expression. So, in other words, we are going to say, let y be the root of this x squared plus 6x minus 5. We know that anything under the square root should be 0 and positive. So to try to plot this, we don't need the negative part. We just need only this part. I want us to plot this expression or this equation in this interval 0 to 5 so that it shouldn't be that big. Right, so we know that we are going to have a 0 here. We are also going to have a 1, 2, 3, 4, and 5. Now, let's substitute 0 here. When x is 0, I'm going to draw a table here and say x, y, and then let's have this 0, 1, 2, 3, 4, and 5. Right, when x is 0, we are going to say root of that plus 6, 0, minus 5, which will then, this will be 0 and this will be 0. So 0 plus 0 minus 5 is going to be root of negative 5, which then breaks the whole thing. Here we're going to have an a, so there's nothing there. I'm going to substitute for all other x values to save time, so you can try to substitute yourself. So this is what I got. After substituting all the x values, I got these y values. Now we are going to try to plot this. Let's say this is 0.5, this is 1, this is let's say 1,5, and this is 2. So when x is 1, y is 0, and I'm going to try to skip these roots to save time, but when x is 3, y is actually 2, right? And when x is 5, y is 1, right? So we can actually see the shape of the semicircle. You can join the points. I'm sure the roots are somewhere there and there, but this is actually the shape of a semicircle. And we can see that the maximum value that we have is at 2, which means our answer A is the correct one. I've noticed that this video might be getting a little bit too long, and I've decided that I will finish the other seven questions in the following videos. So be sure to like and subscribe, and make sure you stay tuned for the following videos that I'll upload soon. And remember to keep education fashionable. I'll see you in the next one.